In this video, I am going to discuss about the DC circuit and measurement. And in the DC circuit and measurement, the first topic, which is very basic topic, what is an electric cell? So, an electric cell is a source of electrical energy which maintains a continuous flow of charge in circuit. It means an electric cell is a source of an electrical energy which maintains continuous flow of charge in the circuit here. Suppose this one is an electric cell, and in this electric cell there are two plates, these two plates, and these plates are called electrodes. One electrode positive and other is what here negative electrodes, these two electrodes. And inside this cell there is an electrolyte. This one is what? Electrolyte. And when the electrode is connected through any circuit, or when this cell is connected through any circuit here, then current will start to take place. And remember this, an electric cell always convert chemical energy into electrical energy. Just this one is a simple word here, electric cell. Now, next topic is electromotive force in a cell, and this electromotive force is also called installed EMF of a cell. And now first question is here, what is the EMF of a cell? So the EMF of a cell is defined as the work done by the cell in forcing unit positive charge to flow in whole circuit. Whole circuit means in external circuit as well as inside the circuit. It means to flow in whole circuit, and in that whole circuit external plus including the cell is called the EMF of the cell. So simply you can say EMF is the work done in forcing a unit positive charge throughout the circuit including the cell also. And always remember this, the EMF of a cell is the characteristics of the cell, and it depends on nature of its plate. Plate means nature of the electrode and electrolyte. But it does not depend on the shape and size of these electrodes, or it does not depend on the quantity of the electrolyte, or it does not depend on the separation between the plates. Dear student, always remember this, electromotive force of cell this depends only on the types of the plate and type of electrolyte. Suppose in this circuit here, this one is a cell, E is the EMF of cell, and this small r is its internal resistance of the cell here. And this r is called external resistance. Suppose at any instant a current I is set up in this circuit. So this one is external resistance and this one is called internal resistance of the cell. Suppose at any instant a current I is set up in the circuit, and when current I is set up in the circuit, then at that time a charge dq flows through any part or any cross section of the circuit in time dt. And suppose dw is the work done by the cell to maintain this flow of charge throughout the circuit. Then by definition, the EMF of this cell E is equal to work done dW to maintain the flow of charge dQ. It means EMF of the cell is given by E is equal to dW upon dQ. And the unit of this one, its unit is joule per coulomb, and joule per coulomb is also called volt. It means 1 volt is equal to 1 joule per coulomb. And this one is a positive terminal, this one is negative, as you know, longer line positive, this one is negative. And the direction of the EMF of cell be always shown from negative to positive, means negative to positive. It means the direction of current inside the cell takes place from negative terminal to positive terminal. While in outside the cell means in outside circuit, the direction of current takes place from positive to negative, but inside the cell from negative to positive. Now, some important points regarding the EMF of a cell, and under this first point is what here? The EMF of the cell, which already I have told you, the EMF of the cell does not depends on shape and size of the electrode, or distance between the electrodes, or amount of or quantity of electrolyte. Second point, we will take a cell. Suppose this one is a cell, any dry cell, this one, and suppose its EMF is 1.5 volt. If the cell is cut into two parts, then each part is behaves like a cell whose EMF is 1.5 volt. It means if any cell having or any dry cell having EMF 1.5 volt, when the cell be cut into two halves, then it will be behave like the two cell, and the EMF of each part is how much here? 1.5 volt. And third point, EMF is not a force. Electromotive force is actually not a force. Otherwise, its unit becomes Newton. But its name is taken historically. Now, the next topic is terminal potential difference. Suppose a cell of EMF E, and here no any internal resistance is given. It means if the internal resistance is not given, then in this case I have not considered the internal resistance of the cell. But when the internal resistance of the cell is given, so that internal resistance will be also considered with the internal resistance. So suppose any cell of EMF E is connected to any circuit, and in this circuit, suppose three resistors, this first one, second one, third one. And this cell is maintaining a continuous flow of charge dq throughout the circuit. It means the cell is maintains a steady current in this circuit here. Suppose dW is the work done by the cell to maintain a charge dq throughout the circuit. Then by definition, the EMF of the cell is given by E is equal to dW. E is equal to dW upon D. This is the total work done by the cell to maintain the flow of charge dq throughout the circuit. But these three resistors are in series, so the charge flow in this resistor is also dq. The charge flows in this one is also dq, and the charge flows in this one is also dq. And suppose the work done by the cell to maintain the flow of charge dq through this resistor is dW1, and to maintain the flow of charge dq through this resistor is dW2, and to maintain the flow of charge dq through this resistor is dW3. It means dW1 is the work done by the cell to maintain the flow of charge dq through this one, dW2 through this one, and dW3 through this one. It means this dW is the sum of dW1, dW2, and dW3. It means we can write here E is equal to dW1 plus dW2 plus dW3 upon dq. Simply. And finally, when you will take separately, then we can write here RE is equal to dW1 upon dq plus dW2 upon dq plus dW3 upon dq. What is dW? dW is the work done by the cell to maintain the flow of charge dq through this resistor, and by definition, this dW1 upon dq, this will give the potential difference, or by definition, this will be the potential difference across the resistor, and which is equal to what here V1. So we can write here E is equal to V1, which is the ratio of dW1 upon dQ, plus V2, which is the potential difference across this resistor, and which is equal to dW2 upon dQ, and plus dW3 upon dQ, which is the potential difference across this V3. It means E is the EMF of cell, and V1, V2, V3 is the terminal potential difference, or simply you can say potential difference across these resistors. So E is equal to V1 plus V2 plus V3. Now, the next topic is internal resistance of the cell. This one is very important, very small part of the cell here. Internal resistance, as it is clear by its name here, internal resistance. And the resistance offered by the electrolyte inside the cell, there will be electrolyte, and the resistance or the obstruction offered by the electrolytes of the cell to the flow of current, and inside the electrolyte, flow of current will take place due to the motion of ions. So I will say flow of current or ions through it is called the internal resistance of the cell. Or in other words, you can say here, the obstruction offered by the electrolyte in the flow of ion inside the cell is called its internal resistance. And the internal resistance is depends on following factors here. First, directly proportional to separation between the two plates of the cell. It means internal resistance of the cell is directly proportional to the separation between the plate inside the cell. If the separation between the plate is more, then its internal resistance will be also more. Second point, inversely proportional to the plate area dipped into the electrolyte. It means if more area of the plate or more area of the electrode is dipped into the electrolyte, then its internal resistance will be less. इसीलिए जब बैटरी में पानी कम होता है तो लोग कहते हैं इसमें पानी और भर दीजिए, डाल दीजिए, तो ज्यादा एरिया जब उसका डूबेगा inside the electrolyte, उसका internal resistance हट जाएगी. Third point, it depends upon nature of the electrolyte, concentration of and temperature of the electrolyte. So, what is nature, concentration, and temperature of the electrolyte? And increases with increase in concentration. When we increase the concentration of the electrolyte, then the ion not easily flow. Then ion will offer more hindrance, more obstruction. So internal resistance will increase due to this reason. And increases. What increases? Internal resistance increases with increase in concentration, but decreases with increase in temperature. When we increase the concentration of the electrolyte, then ion is not really moved. So resistance, internal resistance increases. But when we increase the temperature of the electrolyte, then ion gets more freedom to move inside the electrolyte, and in this way its internal resistance will decreases. Or in other words also you can say here, when we increase the temperature of the electrolyte, then the viscosity of the electrolyte decreases and the ion gets more freedom to move inside the electrolyte. So finally its internal resistance will decreases here. So dear students, today I have discussed here some basic things. I hope maybe that many of them is already have studied in the class 10th here or in other classes here. But these topics is very important before we start the major topic of this chapter here. Thank you.